Hello, and welcome to my tutorial series on how to make a 2D platformer in Unity. In this video, we're going to add our own customizable physics features so that our character can have a little more precision in his side-to-side movements. Please like this video and subscribe to this channel. It helps support this content a great deal. Let's get started. So for anyone who watches this channel, you'll know that I like to show different ways in which things can be done. And recently a viewer ask the question, when we see new vector 2, such as here when we have our line rb.velocity equals new vector 2, what's actually happening here? Is there a whole new vector being created? Or is there something else going on? And the first part is actually the right part. There is a new vector being created, but when we are trying to create a velocity, there's a little more than that going on. So I thought this would be a good opportunity to not only explain that, but to also show an alternative way in which a character can be moved. Now, there's probably at least 5 different ways you can move a character, so I'm not going to be able to cover all of them in this series, but here I can show an alternate way while we're very early on in the development of this project to move a character using force rather than velocity. To do this, I'm actually going to create a whole new controller because this script right here is pretty long and I would have to change a lot of things and it would probably get pretty messy trying to change everything in such a dense piece of script. So I'm just going to create a whole new script and I'm just going to put it in. Here's our player and here's our player movement script. So I would just take this script out and I'll put a new one in. So I'm going to call this new script, C# script. I'm just going to call it player controller. And actually, before I even do that, we're going to create a new folder. And in this folder, we're just going to call it player. And we're going to put these 2 scripts in there so we can keep everything organized. What's my error here? Object reference not set to an instance of an object. Did I hit something or move something here? I don't think so. I'll get back to that anyway. Let's just go ahead and open up our script here and let's get started. So to get started, we're going to declare our variables at the top like we did up here with all these when we declared our movement speed, our vector 3s and our vector 2s and such. So to start off, to keep this organized, I'm actually going to do something a little different in that I'm going to use a header, which is a nice way, or an additional way in addition to comments, a way to organize and label our project. So actually this should be in a parentheses. And our component right now, our only one, is going to be a private rigid body, and like last time, we're just going to simply call this RB, and that's all the components we have right now. Might have more later. And then after this, we're going to have our horizontal movement, and that's going to go there like that. And I think right now the only one we're going to have a couple things. So we're going to have our serialized field, just like we did before. And then we're going to have private float, and we'll call this one move speed. And then we're going to have another private vector 2, and this is going to be called direction. And then actually that's it for those. We're going to add an initial value to our move speed float. So the next header, actually I'm just going to cut and paste this so we can keep this moving along. I'm sorry, copy and paste this. And then this one is going to be called physics, because the difference in using force over velocity is going to be our use of physics and how we're going to manipulate things. And our two physics attributes that we're going to be using here is going to be another serialized field, copy, Control V, because we're going to have two floats we're going to be dealing with. The first one is going to be called max speed, and the second one is going to be called linear drag. So before we go further, we have to fix this. Serialized field should be one word like it was in the previous script. And let's go ahead and add some initial values to our two floats here. Let's just say that equals 7f. Let's say that equals 4f. And in our void start function, we're going to go ahead and call our rigid body component just like we did in this script. We'll just simply cut and paste that right there. And now also what we're going to have is we're going to have a void fix update function in addition to an update function. And that's because we are going to be dealing with physics and we want a fixed time step when we're dealing with physics. And that's something we do with fixed update. Actually, if we go here, actually before that, let me explain that, in update, it's called once per frame, but the time step is not going to be consistent. And in fixed update, it should be 0.02. And I'll go here, and if I go to edit and I go down to project settings, and if we go here and we click on time, you'll see that the fixed time step is 0.02. This is what the time step is when we put anything in fixed update. So going back to our script, inside our update, we're going to go ahead and we're going to create our vector2, or we're going to define it here. We're going to say direction is going to equal a new vector2, and that vector2 is going to consist of an input dot get axis raw. This is very similar to what we did in the previous script, and the axis is horizontal. And then the other component to the vector2 is going to be input dot get axis raw, and it's going to be our vertical, which we might not use today for a simple movement script, but we'll put it in here for when we need it later. So here in our fixed update, we're going to, did I spell everything right? Yep, okay. So in our fixed update, we're going to go ahead and we're going to make a function, and we're just going to call this move character. And actually, we'll go ahead and we'll create another function that we'll get to later called modify physics. Now we'll get to work on putting these two functions together. So now we're going to go ahead and make our move character function. We're simply going to put void move character, a parentheses, and inside our parentheses, we're going to put float horizontal. And if you want a more in-depth coverage about functions and how things are passed through them, go to my C# tutorial on functions, and it explains these things in a lot more detail. And so here we're going to use rb dot add force, and inside that is going to be a vector2 dot right times horizontal times our move speed. And we're going to end that with a semicolon right there. And now we need to pass this through We need something to pass through here. This is just saying there's a float called horizontal. That's right here. But it's up here that we're going to pass it through. And this is just simply going to be direction.x. So direction.x is going to be passed into this function, which is then going to be placed here. All this stuff right here basically is going right where we designated this word horizontal, but to make it a lot easier, we declared it by this variable name right here. And actually, now that I see it, so we don't have any mistakes, this should be rigid body 2D, not just rigid body. I think we have everything here. Let's hit save. Let's go back into Unity and see how this all came out. The modified physics does not exist in the current context. All right, actually, we're not using this function. So let's go ahead and just comment it out so we don't have any issues. Now I placed Tofu Boy here at the end. So you'll see that when I hit play, he kinda, oh, actually, no, we forgot something. Got to go here and get rid of the old component. So we're going to go over here and we're going to hit remove component to get rid of the old script. We were using the previous script. And then down here, go to add component. And if you just type in player, you'll get our new player controller. Now this is attached to this, or you could have just dragged it over. And then now here's our initial move speed, physics, and other components that we put in. Now we're gonna hit play. And now as you can see, when I hit play and I move, the character starts out slow and then he speeds up. So the reason that happened was because going back to our script, we used a force instead of where's our movement? This velocity right here. So the velocity basically gives us our speed right away. Going back into Unity, if this was our velocity down here, we would automatically go to 10. Actually, I'm going to pick this up a notch so you can see the speed a little better. So if it was velocity, we'd automatically go to 10. But when we go to 20, or whatever our number is, it speeds right up. And that's how fast we're accelerating. Now, the biggest problem is that this is going to keep accelerating into pretty much infinity. So we're going to have to put something in to sort of cap it down a bit. So we're going to go back into our controller here. And we're going to add if mathf rb dot velocity dot x is greater than max speed, which we're going to set, then what's going to happen is the RB dot velocity is going to change to a new vector 2, and this new vector 2, and I'm going to type out this one part, math f dot sine rb dot velocity dot x, and this is going to be multiplied by max speed, comma rb dot velocity dot y. And semicolon at the end. Let's just make sure I got all this right. Sometimes I don't talk and type well at the same time. Mathf dot sine rb dot velocity dot x times max speed, comma rb dot velocity dot y, and that's all that new one, max speed. All right, that looks good. So basically, you know, if our velocity is greater than our max speed, then it's going to turn this into this new vector 2, which is going to be composed of this math f sine rb dot velocity dot x times max speed. And what this dot sine rb dot velocity dot x line is all about is if we go down here, earlier in our old code, we had to type in that the input get access raw was greater than 0 and less than 0. This right here, actually what it does, oh, we forgot something. We forgot the dot absolute value. That was the whole reason for us putting that mathf right there. So anyway, this sign basically does what these two pieces of code are doing separately. It's going to create the sign in another direction. It's going to create it positive in the positive direction. It's going to be negative in the negative direction. So let's go ahead and hit save. Go back into Unity, and I'm going to up this to 20, and I'll leave the max speed at 7. So now when I hit right or left, it has that very quick acceleration because I made it 20, but it caps itself out at 7. He doesn't start taking off and running and his speed increasing into infinity. So now, actually, let's play so I can show you. So now what we have is when I hit this and I let go, I have this slide here. So we don't want that. We want him to be able to stop when we let go of the button. We want to have precision to his movements. Now, one way we can solve this matter is to play around with the linear drag here, but this is really, if we increase this, it's really not going to be very helpful because it's going to bog down his speed. We want to have his speed as is, or whatever we adjust it to, but we want him to be able to stop. So that is why we use the physics in the first place, or why we are incorporating physics and using our force, is so we can manipulate these things to our liking. So down here, we're going to go ahead and create void modify physics, and inside here, we're going to create if the absolute, oh no, wait, messing everything up. If mathf dot absolute direction dot x is less than 0.4f, and then here we're going to go ahead and put rb dot drag is going to equal our linear drag, and after that else, what we're going to have after that, rb dot drag is going to equal 0f. So this way that when our mathf direction x gets lower than 0.4f, when it lowers it to this point, it's going to start adding the linear drag. Then when it doesn't, the drag is just going to go back to 0. So let's go ahead and hit that. And hit play. We'll leave our numbers as is right now. So now I can go ahead and get that very quick speed, but the minute I let go, he slows down a lot quicker. And I can always increase it by increasing the drag down here. I can make it so it'll fit the precision I want. But I think I'll leave mine like that for now. That's good for right now. So the other problem we have to resolve is that he seems to slide a little bit when we change directions. So what we want to do is add a little bit of a boolean that is going to be able to tell when we change directions, and then be able to make that movement a little smoother. So we're going to go down here, and right above our drag right here, actually no, it's going to be outside of our if statement, sorry about that. It's going to be up here. We're going to create a bool, and we're going to call our bool changing directions. And then this is going to be equal to direction.x. And we want to make sure it's greater than 0 and that RB dot velocity dot x is less than 0. And now we're going to actually just keep that there. And the other thing is, or we want it to be direction dot x less than 0 and RB dot velocity dot x greater than 0. So basically what it does is we just mirrored these two to account for both sides when we created this bool here. Let me just double check this. Direction dot x greater than 0 and RB dot velocity dot x less than 0. Or, and I probably have never mentioned this before, but when you have these two straight lines up here that you type in, that means or as opposed to and. Direction dot x less than 0 and RB dot velocity dot x greater than 0. That's correct. And so what we're going to do is that in here, in our if statement here, where we have our math.f abs direction.x less than 0.4, and then we're going to add our or changing directions as the other two things it has to choose between. So let's go ahead and click on that and make sure there's no errors. There are none. So now we should have just a little bit more smoother. Yeah, look at that. That is way better. We should have a tighter movement right there whenever we want to change directions. And actually, just to show you a little bit of how this works, we can also, let's say I want to increase that to 8. Where do we go here? If I want to increase the drag to 8, I can also, look how quickly he stops, but he does not lose that initial acceleration. And he changes directions very quickly. So this is what we're looking for in our precision movements, which are definitely much more precise than they were in the old script. And we did this by being able to access a new tool here and being able to use things like add force into our script as opposed to velocity. Actually, technically what we did is we actually used both here. We interchanged both. In some places we were using new vector 2s, and we weren't using velocity, we were just using velocity as a measurement. So that's it for today. Thank you for watching. Like this video, subscribe to my channel, follow me on Facebook and Twitter, and support me on Patreon. All links are in the description below. And a big special thanks to all my Patreon supporters. See you next time.